Hello everyone, my name is Shambhavi and welcome back to my channel Fun with Data Science. So today we are going to see about the binomial distribution, that what is binomial distribution, what are the properties of binomial distribution, and after that we will see binomial distribution probability distribution functions, right? And we are going to see one example also for today. So now let me introduce you to some properties for binomial distribution and what are the things that constitute binomial distribution, right? So like if you want you can just write down with me because like they are very simple ones and you need not to like waste time for seeing the videos again and again for writing those things. Okay, so you can just write it with me. So now let me start with the first one, binomial distribution. So binomial distribution has fixed number of trials. Fixed number of trials. Okay, so a binomial distribution has a fixed number of trials. Okay, and here we have now second there is a like you can say a denotation that is n. So basically in binomial distributions we use n, and now what is this n used for? N denotes the number of trials. So basically n denotes the number of trials. So just let me write that. Okay, so see, what was the first thing that in binomial distribution we have fixed number of trials, right? And in the second, what I told you that here we simply write a n, and when I'm going to tell you the formulas for binomial distribution, then you will see that we are using n. So what is this n? This n is denoted, and yeah, it denotes the number of trials. That how many number of trials are going to be in our problem. The problem I can say an example, right? In our in a question which we are getting, right? So this is the thing, that fixed number of trials and n denotes number of trials. Now moving towards the third, what I have is that there are only two possible outcomes. Now let me write that. Two possible outcomes, and those two possible outcomes are success and failures, right? So they are named simply, and let me write it here, success and failures. Okay, so in binomial distribution we have two possible outcomes, that are success and failures, right? Now one thing which I want to tell you, here are some more like denotions. Like simply if I wrote P, so what is P? P is the probability of success of a trial. So P is the, let me write it, probability. I'm writing the short form, PROB, probability of success of a trial, right? So basically here what was n? N denotes the number of trials. Now P, what does P denotes? P denotes the probability of success of a trial. And then I have told, and one more thing is here, that is failure. So Q denotes the probability of failure of a trial. So basically this is the thing, here these three terms are used, and only these three terms also constitutes the formulas for mean, standard deviation and variance. Okay, which I'm going to tell you in a little bit time. Okay, so just let me once more tell you that n denotes number of trials, P denotes the probability of success of a trial, and Q denotes the probability of failure of a trial. So I hope you will remember this by the whole video, right? So these three were the things, and now one more important thing, that P is the probability of success of trial, right? P plus Q, and Q is the probability of failure of a trial. So both these, when they sum up, they will always be equal to 1. So here what is this? That the probability of success of trial and when the probability of failure of a trial, they both are sum up together, they will always result the output as 1, right? So now let me give you an example. Let's say we take a name, and that name is Joe, right? And no, I'm not going to write, only going to speak that example, so like you can listen. So basically let's say Joe always you can say Joe is going to give an statistics MCQ exam, right? And Joe always guesses the correct statistics question and answers. Okay, so now let's say the probability for guessing the right answers, that is the probability for a success of a trial for Joe is 0.6. Okay, now if I want to find what is the probability of failure of a trial. Now trial, what is it here? Trial means that Joe is going to you can say guess the output, or you can say guess the answer of a statistics MCQ question, right? The example which I have taken here is that Joe is a boy and he guesses the correct answer of a statistics question, and the probability for that is 0.6, right? And the so if he's going to like guess the correct answer, so the probability for success, we will be taking the probability of success because the answer is correct, right? So what I have taken here is that, let's say the probability of success of a trial is 0.6, which Joe is doing, right? And now if I want to find the probability of failure of a trial, so what I will do, simply I have this thing that P plus Q is equal to 1. So what I can do is that I would simply write 0.6 plus Q is equal to 1. So when I'm gonna take the 0.6 this side, and when I'm going to subtract it by 1, so the output which I would be getting is 0.4. And yeah, I don't need to write and explain you all the things because this is basic simple mathematics and you all must be knowing that, right? So the thing is that if I know the probability of a success, or if I know probability of a failure, then I'm going to find the other thing which I don't know, right? So here what I was having an example that Joe guesses correctly statistics questions. It guesses the output correctly for a statistics question. The probability is 0.6, right? So the output which I would be getting for the probability of failure of a trial is 0.4. I hope you got a you got a proper intuition that what is the binomial distribution, what are the proper properties of this. Just let me take these properties once more, and I'm going to only just say these, that a binomial distribution has a fixed number of trials, right? And then the next is n denotes number of trials, and third is there are two possible outcomes, success and failure, right? And here we have two more terms that are P and Q. So basically P is the probability of success of a trial and Q is the probability of success of a Q is the probability of the failure of a trial, right? Now we have seen that P plus Q is equal to 1. So basically the summation of probability of success of a trial and the probability of failure of a trial is always be equal to 1. So if I don't know probability of success, or if I don't know the probability of failure, if I know any one of these, so I can simply find the other one which I don't know, right? And this I have shown you using an example which I have taken, that Joe guesses correctly on a statistics statistics MCQ question, right? So that the probability for guessing was right. So here the probability for success, that's why I have written P here. So he is getting the he is guessing the answers correctly, right? So basically he is getting a success, right? So what I did here is that I simply write a small p and I give it as 0.6. And now I want to find a small q, that is the probability of failure of a trial. So what I'm going to do is that I will simply write 0.6 plus q is equal to 1. So when I will take the 0.6 other side, so it will just become 1 minus 0.6. And yeah, 1 minus 0.6 is 0.4. So I got the probability of failure for trial is 0.4. And yeah, I hope you got that little point that what's this. And now just let me have some space here. Okay, let me take this example a little bit more downside because I need to explain some more things to you, right? So just give me some space. Okay, fine. And now let me go back upside. And now I told you about the binomial distribution. Now I want to I want to tell you about the binomial probability distribution. So basically the outcome of a binomial experiment fits a binomial probability distribution. Now what is it that I am saying? So now let's take a random variable. Okay. Now random variables I have already discussed in the previous video, so you can just go and watch them. I'm not going to revise the things today here, right? Because otherwise it will take a very long time. So basically we denote the random variable using x, capital X. Now let's say that the x is the random variable, and let's say number of success obtained in the n independent trials. So basically what is this random variable x? It is the number of success obtained in the n independent trials. Now what I want to say with this is that when I will tell you the example, then you will get a proper note that what I want to convey from here. Now just let me tell you about some formulas which we will be using for this binomial distribution thing, and just let me change the color. Okay, so now here we have mean, variance and standard deviation, all the three formulas. So let me just write So okay, we simply denote mean using mu, right? This was the previous thing also which we were doing, right? Mean mu. And I'm going to write the formula in front of it only. So the formula here for the mean is n into p. Now, what was n? We have studied earlier that n was the number of trials, right? So the number of trials multiplied by the probability of a success of a trial is the mean for the binomial distribution. Now let me take you again to the upside and see here what I have written for n. So basically n is the number of trials, right? So here in the mean one I have written n. After that, what was p? Now p was the probability of success of a trial, right? So the mean which we are getting here for the binomial distribution is the number of trials which are multiplied by probability of success of a trial. And basically this is our mean and which is denoted by mu, right? So this one is the formula. When I'm going to tell about the example, then you will get the proper one. And okay, this is the formula for mean here. Now next comes the variance. And variance. Now what is the denotation for variance? And it's the same as sigma square, right? For like binomial sigma square, variance for binomial probability distribution, right? We are discussing with the probability distribution, binomial probability distribution. Okay, so here the mean was mu is equal to n into p, right? Now variance is sigma square, and sigma square which is equal to n into p. It is the same as the mean, but one more term adds here, that is q. Now what was n? I hope by the time you all have learned that what is n. So let me revise that. N is the number of trials. P is the probability of a success of a trial, and Q is the failure. Q is the probability of a failure of a trial. As we have seen just few seconds before that we have discussed about P and Q in a very brief way. I have even taken an example, right? So this was the formula for the variance, and just let me revise that sigma squared is equal to n into p into q. N is the number of trials, p is the probability of success of a trial, and q is the probability of failure of a trial. Okay, so this is about the variance. And yeah, I know if you have just watched my previous videos, like if you're continuing all the like playlist, then you must be knowing about what would be the standard deviation. So here the standard deviation. So I have already told all these things in a very much detail, that the standard deviation is the just root of the variance. So what we do is simply, and okay, just 1 second, just let me put this colon, and here what I'm going to do is that I'm simply going to write sigma, and under the root I'm going to write NPQ. So basically if you are going to write this in short form, so basically it's sigma under root of this thing NPQ. So this is the standard deviation which we follow for the formulas. And just let me make a big square so that it's clear that it is a formula. Now just let me quickly revise all the formulas with you. So basically the formula for mean is that we denote it using mu, and the formula is n into p in number of trials, and p is the probability of success of a trial. Then variance is denoted by sigma square, and the formula is NPQ. And here Q is the probability for failure of trials. And when I'm going to write about the standard deviation, it's simply sigma, and which is equal to under root of NPQ. And I have told about NPQ many a times, so now I'm not gonna repeat all the things, right? Now, just one more thing before the example, and sorry, let me go a little down once more, and let me take this example a little more down. Okay, so I'm so sorry, and yeah, that's fine. Okay, now absolutely fine. Now just let me tell you that how do we denote. Simply, what is the notation for writing the binomial probability function, right? So this simply, it is written as x. Here this b is binomial, right? This b is refers to the binomial, and in bracket n comma p. Okay, let me write this n in a little clearer handwriting, and let me choose that orange color again, and this. Now I'm not going to tell that what is n and p, right? Because I'm telling this from the very starting of this video. Now I can't repeat this once more, right? So this is basically the denotation for, like, we write this binomial probability function like this one. Okay, so this is the thing. Now let's move towards the example quickly, and let me give you an idea that how do we do the things. So basically this is an example, and let's first read the question that what it is saying. So the question is, it has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. If 20 adult workers are randomly selected, now find the probability that at most 12 of them have a high school diploma but do not pursue any further education. How many adult workers do you expect to have a high school diploma but do not pursue any further education? The question is written in a very simple English language. If you haven't heard like what I'm saying, you are gonna confuse. So just pay a little bit attention towards this question. Okay, question is written in a very simple English. You can even see it and you can even understand it on your own, right? So just let me change the color and let me take a new color, and then we are going to write the, like, you can save answer. Now, like, what is the question is that what we need to do is that we need to find the probability that at most 12 of them have a 12 of them have a high school diploma but do not pursue any further education, right? So now this is the answer. Now let's say, okay, let's say here capital X. Now it is a random variable, right? Capital X, random variable. So capital X is the number of workers who have a high school diploma, right? Who have a high school diploma but do not pursue any further education. So this is the same thing which it is written here, and I have said that let's say X is equal to number of workers who have a high school diploma but do not pursue any further education. So this is like we are assuming it as X, and it is like a random variable for us. Okay, so I have highlighted it because I'm not going to write this again because it's like a little lengthy and it will consume a lot of time, so I'm not going to write it. Okay, so this is X. Now let's say this is the highlighted line which refers to the X, and let me just simply add number of workers. Okay, now next what I'm going to do is that it is simply written here that if 20 adult workers, now how many trials we want to take, right? We want to take 20 trials. So what I'm going to do is that I'm simply going to do that X is equal to, and I'm going to give it as a value of 0, 1 up to 20, because it's written that the number of workers we are going to take 20 adult workers, right, which are randomly selected. So in X I have 20, 0 to 20, right, because we are going to take 20 workers. Now what I need to do is that, now here let me tell you that what is the N. N is the total number of trials, right, which I told you that previously. So basically here the total number of trials are 20, right, because we are taking 20 workers, so trials would be also 20. This must be clear to you. Okay, now what I need to do is that I need to take the probability for success. Now let me tell you success of a trial. Now what it is saying, it has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. So what it is written that 41% of adult workers have a high school diploma. So from here I got to know that my probability for success of a trial is 40%, that is 0.41. Now if once I get to know about what is the probability for success of a trial, I can easily find out the probability for a failure of the trial. So the formula for the same is P plus Q is equal to 1, right? So I want to go a little down, and simply I will enter the values. The value for probability is 0.41 for P, and Q it's nothing, and then I need to write 1. So from here only I will simply get Q is equal to 1 minus 0.41, and when you are going to subtract this, the output which you are going to get is 0.49. So from here what I got is that the probability for failure of the trial is 0.59. So now from till here I have received all the things. all the things, in the sense I have received all the values. I have q is equal to 0.59, I have p is equal to 0.41, and I have n is equal to 20. So now, is there any problem in finding the mean and standard deviation and variance? No, there's nothing problem in finding these things. So when we were saying that x is equal to number of workers, and let me check that what was the full statement for that. Yeah, when we were saying that x is equal to number of workers that have a high school diploma but do not pursue any further education, right? So for that, we need to find the mean. Okay, so we need to find the mean, and for finding the mean, what's the formula? The formula was mu is equal to n into p. So now n is equal to 20 and p is 0.41, and when you are going to multiply both those things, the output which you will be getting is 8.2. So basically this is the mean. And now if you want to find the standard deviation and variance, now let's find the standard deviation. You will find the variance on your own. Okay, I'm not going to do that. So simply I'm going to write NPQ, and then under root I'm going to do 20 into 0.41, and the value for Q was 0.59, and it's simply like this. And now let me go down once more, and when you're gonna multiply all these things and give a root, the output, the final which you will be getting is 2.20. So this is the standard deviation for your question which you have find. So I hope you got the idea how to, what are the formulas for this, how to apply these formula, how to see that what is p, and what are random variable which we need to take, what is the n value which we need to take from the question. So my main motive from this question was to tell you that how to find the p, q, n, capital X, all these things, like seeing like you have these statements and how to find out these values from this statement. So today we discussed about the binomial distribution, its properties, then we have discussed about some terms, then we discussed about the mean, variance, standard deviation, then we discussed that what's the denotation for this binomial probability distribution, then we moved to a question and we simply solved this question using the formulas which we have already seen. So I hope you got today's video, that what was the topic and what was the main idea behind these topics, right? If you have any doubts, you can just rewatch this videos, or you can just comment me in the comment box and I will reply to your questions. And yeah, don't forget to like, subscribe, and share the channel. So this is all for this video. Till then, thank you and bye bye.